All right. So back with the coordinate geometry, guys, and we'll continue from where we left off yesterday. So we have gotten to parallel and perpendicular lines, right? So we did a lot. I'm not gonna bother to recap because this was just yesterday, right? So I'm assuming that this is a continuation from yesterday, and I don't need to recap. But I sent out the video. Hoping person would have looked back at the video. I spoke about length of a line, spoke about midpoint of a line, spoke about gradient of a line, spoke about the equation of a line and the two forms y equals mx plus c, and also y minus yp equals m bracket x minus xp. And I said that that second form was my BFF form because it is used when you have a gradient and a point. We also said if you're ever trying to find the equation of a line, you must know two things about that line. You must know the gradient, and you also must know, you must have a known point on the line. All right. What else did we talk about? We spoke about how you can find the equation of a line from a graph. And an important thing there was that you have to ensure that you have two exact points. You must be using two exact points, 2 points that you know for certain, the coordinates. All right. We also spoke about reading the equation, reading the gradient and the y-axis intercept from the equation of a line. And the important thing there is that we have to put it in the form y equals mx plus c. Right? Don't try to read the equation of a line unless you put it in the form y equals mx plus c first. Right? So these are some of the things that we did yesterday. And today now we're following through with the relationship between parallel lines and perpendicular lines. All right. So the relationship really is about gradient. Right? The relationship between parallel lines and relationship between perpendicular lines have to do with gradient. Gradient or the slope of the line. And it's kind of common sense. In particular with the parallel lines, because parallel lines are heading in the same direction, they have the same slope, and so the gradients are the same. So parallel lines have the same gradient. All right. And then perpendicular lines now have what we call negative reciprocal gradient. And it's such that if you multiply the gradient of two perpendicular lines, the product of the gradients is -1. So multiply the gradients of two perpendicular lines, it will be equal to -1. And so you'll have to solve questions when they talk about parallel lines and they talk about perpendicular lines from time to time. So if you ever do a coordinate geometry question and the whole business of lines being parallel come into play, the thing is that they have the same gradient. If you ever do a coordinate geometry question and they start to talk about perpendicular lines, and what it is, you know, the product of the gradients equal -1. And there's another way that we can show the relationship between the gradients. So let's go to it now. All right. So let's talk about parallel lines first. And this is it. I've shown two parallel lines on the diagram here. All right. And you can see it. You can see them. And you can see there that parallel lines have the same gradient over on the right. They have the same gradient. So the gradient of line 1 is equal to the gradient of line 2. So if the gradient of one of the lines is 3, then the gradient of the other line is also 3. The gradient of one line is -half, the gradient of the other line is also -half. Whatever the gradient of one line is, the gradient of the other one is the same. What happens is that they might have two different y-axis intercept. As you can see here, the y-axis intercept is different. All right. But they have the same slope. So these two gradients will be equal. So if you know one gradient and there's a line parallel to the one, if you know the gradient of one line and you know that there's another line that is parallel, then the gradient of that other line must be the same. This is as simple as that. So parallel lines pretty straightforward. Parallel lines have the same gradient. All right, as simple as that. So this is it. When two lines are parallel, their gradients are equal. So the gradient of one equals the gradient of the next one. All right. So if I have parallel lines, line 1 and line 2. If the gradient of line 1 is equal to 6, then the gradient of line 2 is also equal to 6. Simple as that. The gradient of line 1 is negative half. The gradient of line 2 is also negative half. The gradient of line 1 is minus 4. The gradient of line 2 is also minus 4. And if you know the gradient of line 2 first, is 3, and they are parallel, then the gradient of line 2, line 1 is the same 3. And that's relationship between parallel lines. Talking about a line 1 and a line 2. They are parallel, meaning they are heading in the same direction. So this line and that line heading in the same direction, parallel. All right. If there are two negative gradients like this one sloping down, then this one sloping down with the same gradient. This one also will be sloping down, negative. This one will be sloping down. This one will be sloping up, same gradient as this one sloping up. Parallel lines have the same gradient. I'm going to do a question to apply this information. All right, so that's parallel lines. Perpendicular lines now are a little bit different. Perpendicular lines have what I call negative reciprocal gradient right here. All right, and this might be the only class where you hear somebody call it, say it like that. Most persons tend to give it this, that the product of the gradient is equal to negative 1. But for the purpose of calculation, this statement is very friendly for the purpose of calculating gradient if you know one of the gradients. And what it is, if two lines are perpendicular, and these are two perpendicular lines in this diagram, right? Two perpendicular lines, red lines in that diagram. All right, so you have line 1 and you have line 2. All right, and you can see there that they cross each other at right angles. They are perpendicular. Cross each other at right angles right here. All right. So when you want to show that two lines are perpendicular, you can do this. You can multiply the two gradients, and if the product is negative 1, then you know that they are perpendicular. All right. You know that they are perpendicular. But for the purpose of calculating gradient of one line from the next one, it is good to do this thing. Recognize this. And that's what this statement means. This statement right here means this. Negative reciprocal gradient. The gradient of one line is equal to the negative reciprocal of the next line. Right? Negative reciprocal. So the negative reciprocal of 4, for example, the negative reciprocal of 4 is negative 1 over 4. The reciprocal of 4 is just 1 over 4 now. But the negative reciprocal is 1 over 4. Reciprocal means 1 over. So for example, if I have 3 over 2, reciprocal of 3 over 2 is 2 over 3. When I flip it, that's a reciprocal. And then the negative reciprocal of 3 over 2 is negative 2 over 3. Negative reciprocal. If you have the gradient of line 1 and you want the gradient of line 2, then you can use this. Same thing, same formula. The two formula is the same formula. Right? Gradient of line 2 is minus 1 divided by the gradient of line 1. All right, so instead of doing all of that, there's a simple way to see that calculation. Simple way to say it. And this is it in this box right here. And this is what I want people to remember. This is where you go from one gradient to the next when two lines are perpendicular. Up here, when two lines are parallel, you don't have to do anything. You just have the same gradient. Right? But when they are perpendicular, as I said, this is what I want you to use. Flip it and change the sign. That's what this calculation is. This calculation is to flip the one that you have and change the sign. And that's where you go from one gradient to another gradient, another perpendicular gradient. So when two lines are perpendicular, the gradient of one is equal to the negative reciprocal of the gradient of the other. And we say we flip it and change the sign. Flip the one that you know and change the sign to get the other gradient. So I'm going to do a couple examples over here. Remember also that this is very important. The product of the gradients equal -1. Right? These two formulae can be derived from this, can be derived from that, and it can be derived from that. So all of them really saying the same thing. Right? But for the purpose of calculating one gradient from another one, when the lines are perpendicular, this thing right here is what you want to be using. Flip it and change the sign. All right, so look over on this side now, on the right side. I'm going to write a couple examples, right? Let's start up here. I'm going to write a couple examples. So let's say we have perpendicular lines, and this is a symbol for perpendicular. So instead of writing out the words, I'm just going to write that for perpendicular. Perpendicular lines. This is a symbol for parallel lines, and I put two strokes like that as parallel lines. So we do that in the exam, they'll give you the marks as you see. So we have perpendicular lines. All right. So we have line 1, and we have line 2. And the relationship between perpendicular lines has to do with the gradient. Gradient of one line is a negative reciprocal of the next one. And I'm saying to calculate one gradient from the next one, when the gradient, when they are perpendicular, you flip the one that you have and change the sign, and that will be the gradient of the other one. All right, so let's go now. So two perpendicular lines, line 1 and line 2. Let's say the gradient of line 1 is 3/2. Let's start with something straightforward. What will be the gradient of line 2? Somebody tell me. Flip it and change the sign. Sign meaning positive or negative. Right now, this is positive. Right? And two perpendicular lines cannot have the same sign. Meaning, if one gradient positive, then the other perpendicular gradient must be negative. If one gradient negative, the perpendicular gradient must be positive. But you also flip it. All right, so tell me now. Somebody unmute your mic and tell me what will be the gradient of line 2 if the two lines are perpendicular. Flip it and change the sign. Somebody tell me. Yeah?
-2/3, sir.
Just like that. Flip it and change the sign. -2/3 will be the gradient of the perpendicular line. As simple as that. Sweet. Let's do another example. Let's say the gradient of line 1 is -4/5. What will be the gradient of line 2 if they are perpendicular? What will be the gradient? Somebody tell me what will be the gradient. Yeah, perpendicular.
-5/-4.
No, flip the whole thing. Flip it. This gradient right now is a negative gradient. So the perpendicular gradient is just going to become a positive. So you flip it and you change the sign from a negative to a positive. That is all you know.
Sure, 5/4.
Right? So it again. So it's going to just become 5/4. So what she says is kind of correct still. Now she's saying negative over negative, but the negatives cancel. So you don't need to put the negative. Just recognize that the gradient of this one is a negative gradient, and so this one has to be a positive gradient. So you change the sign from negative to positive. All right, so far so good? All right, let's go now. Let's say the gradient of line 1. Let's say the gradient of line 1 is 1/3. Let's say 1/3. What will be the gradient of line 2? They are perpendicular.
-3/1.
-3.
Come again?
-3/1. -3.
-3/1, Jesus, -3. Anyway, what is that? -3. All right, let's do another one. Suppose the gradient of line 1 is -2. What will be the gradient of line 2? So the gradient of line 1 is -2. What will be the gradient of line 2?
Half.
They are perpendicular. Half. Very good.
1/2.
Very good. Because this -2 is same as -2/1, really. All right. So to become, I change the sign to become a half. like that. But go to understand that? So that's
Yes,
the
sir.
relationship between
Yes, sir.
perpendicular lines. That's a quick way to calculate one gradient from the next. When you know one gradient, and you want to find the other one. And there are going to be questions where they'll give you one line and they tell you to find another line that is perpendicular to it. And you have to use the gradient relationship. Flip the one that you have and change the sign, and that will be the gradient of the other one. And then you can use that gradient in calculation. So we have to understand this before we get to those questions. But good, I think we can move on.
Yes, sir.
So
Yes,
it's in
sir.
parallel. It's in parallel, we don't have to do anything. Perpendicular, that product will be equal to -1, right? Because this 3 would cancel this 3, and this 1, this 2 would cancel this 2, and so you get -1 right here. So the product of the gradient of perpendicular lines will be equal to -1. But most times, what will happen is that they'll give you the gradient of one line, and you need to use it on the gradient of another line, and this is called a perpendicular gradient. The perpendicular gradient is obtained by flipping the one that you have and changing the sign. So can I move on from this, guys? Think you have it?
Yes, sir.
Can I move on from this? All right, good.
Yes.
All right, lovely. Okay. Moving on. So what we're gonna do now is an example of how we can apply that's what we just did. We're gonna apply what we just did. All right, so that's what we're doing next now. Applying what we just did. Right here. All right, I wonder if I can just clear all on this thing. I don't need this again. Let me clear this all. All right, let's get a new page for anything. All right, so look at this example now. Example 1. Looking at example 1, it says find the equation of a line which part the made is smaller, so we can set it up for you. Do it over here. All right, it says find the equation of a line passing through the point Q23 and parallel to the line 2y equals x minus 5. So let me set this up for you now, what they are basically saying. So it is like you have this line, you have this point, you have this point, you have that point, and you have a line passing through that point. That line is parallel to another line that they gave us over here. So they gave us another line over here, and they said those two lines are parallel. And what they did, they gave us the equation. In fact, let me draw that other line black, the one that we're not going to work in it, so you can see it. So they told us that that line that we want, this line,
Sir.
all right, guys, sorry about that. All right, so this line passing through this point, Q, and Q has coordinates 2, 3. And what they have said is that that line is parallel to another line. So there's another line. Let's put the line up here instead. There's another line up here that is parallel to that one. And the equation of this line, let's call this line 1. They give us line 1. And the equation of line 1 is it's 2y equals x minus 5. And they're asking us to find the equation of this line, line 2. We want to find the equation of line 2. All right, so remember now, if we want to find the equation of line 2, we need to know 2 things about line 2. What are the 2 things we need to know about line 2 to find the equation of line 2? Somebody tell me. What are the 2 things we need to know about line 2 if we're going to find the equation of line 2?
Sir, the gradient.
Yes, and
And
we need to know 2 things. And
the
a
length
known
of
point.
the
No, the gradient and a point. Remember, watch me now. Look over here. If you're going to find the equation, you want to use the BFF formula. You want to write y minus yp equals m into x minus xp to find the equation. So what are the 2 things you need to know? Right? To get that equation, to use that equation. You need to know this. You need to know this and this. This is the gradient, and these 2 are your known points. That's all you need to find the equation, So you need the gradient and that point. Xp and yp are the known points. The y and the x out here. Those are just your general values, general. Right? So those coming back anyway. It is the xp and the yp you need to know. And you also need to know the gradient. So that's where we always start. You cannot forget that. Once a question asks to find the equation of a line, which is what this question is asking us to find right here. It's asking us to find the equation of a line. And then they describe what the line did. They're giving us some information about the line. Right? Find the equation of the line. And then they go on to tell us what the line did. It passed through a point Q, and it is also parallel. The line that we want is parallel to another line, which is 2y equals x minus 5. Once you see the word parallel in an equation, in a question, so you have 2 lines with the same gradient, parallel. So the gradients are the same. And they give you the black line, they give you the equation of the black line. Because they gave us the equation of the black line, we can extract the gradient of the black line from the equation. How do we extract the gradient of the black line from the equation? Tell me, how do we get the gradient from it? What do we have to do? How do we extract the gradient from the equation of a line? This is the equation right here, this. How do we get the gradient from that line, from that equation? What do we have to do?
The rise over run.
Rise over run is when you have points. And then look over the notes, These answers say to me, you did not look over what we did yesterday. We did a slide where we said extracting or deriving the gradient of a line from the equation. We did that yesterday. Let's make it find it. Since I'm gonna go back. See there? Read it. That's what we said. Reading the equation of a line. And what did we say you have to do? See there? You have to put it in the form y equals mx plus c if you want to get the equation. Right? Now, this one that you're looking at right here, so now. This one that you're looking at. Similar to what we have over here now, Similar. 2y as a subject. And what did I do? I divide by the 2. I have to bring it in the form y equals mx plus c. So when they give you the equation of a line and you want to find the gradient, you have to bring it in the form y equals mx plus c. That's what you have to do. Bring it in the form y equals mx plus c. Alright? So that's how you get the gradient of the black line. Now when you get the gradient of the black line, you know that the purple line have the same gradient. So that way, that is how you're gonna find the gradient of the purple line. You understand? So see here now. You going back to the black line, divide by the 2, tells me that the y is actually equal to half x minus 5 over 2. That's the equation of the black line, That means that the gradient of the line 1 is actually equal to half. See there? So I know the gradient of the black line now is half. Eh? No, because the gradient of the black line is half and then parallel. Then I also know the gradient of the purple line now. The gradient of the purple line, which is line 2, is equal to the gradient of the first line. Why is it equal? Because they're parallel. And the gradient of the first line is a half. So the gradient of line 2 is also a half. See there? The gradient of line 2 is a half. And now can find the equation now. Because remember, to find the equation of a line, you need two things. What are the two things you need? You need the gradient, which I have here now, and you need a point that the line passes through. So now I can find the equation of the purple line using those two things. Simple enough. If you remember that to find the equation of a line, you need to know two things, which is something that we did as well over here. See there? Or summarize. The last thing that we did yesterday, you have to look over your notes, guys. That's what I told you to do. See there? Right here, so. That's what I told you. To find the equation of a line, you must know two things. So those are the two things you're looking for if you want to find the equation. You need a gradient and you need a known point. I said if the known point is the y-axis intercept, you just use this. Y equals mx plus c. But if the known point is not the y-axis intercept, some other point, as is the case here with the q, then you have to use the BFF formula right here. The BFF equation of a line. Right? But instead of P, we're going to say Q. Simple as that, right? You have to cover your notes and watch all the videos and these things. Right? So this is where we're at now. Let's go back. Perpendicular lines. And they will be the example. Right. So that's where we're back at now. Right? So I'm searching for the gradient because I don't know the gradient. But they give me information to find the gradient. What information did they give me to find the gradient? They told me that this is parallel to that line. So if I can find the gradient of that line, then I will have the gradient of the line that I want, which is the gradient of the purple line. Right? So let's go now. So now that I know that the gradient is the half, I can now do the equation of the purple line. So let's do it. Let's work it out in purple right below it. So the equation now, right below it, I'm doing it. The equation of this line now, the purple line, is y minus yq, because it passes through q, equals the gradient of line 2, calling it line 2, into x minus xq. And you just put in the values there now, and you're good. Right? What are the values? It is y minus yq is this value right here, the 3. Y value q is 3. So it's y minus 3. Right? Let's say the point is 2, 3, not 1, 3, no. 2, 3. Equals, the gradient is a half, bracket, x minus xq is the x value q is that, which is 2. Right? It's 2. And that's my equation. I just need to simplify now. We simplify when we have a fraction here. So what do we say? We say multiply this across this side and multiply the 1 in there. And you have a fraction as a gradient, right? So we're going to get 2y minus 6 equals x minus 2. And then what we can do now is transpose the 6 over here and it becomes positive 6. Y equals x plus 4. And we can divide by this 2 now if we want to put in form y equals mx plus c. So we get y equals half x plus 2. If you divide 2 by 2, or you say multiply 2 by a half. But understand that? That is that line. Very good?
Yes, sir.
Huh?
So you can go back again.
Go back again. Which part do you want to go over? Or me get the equation?
Yes, sir. Yes,
I'm going to go back again. Go back again. Alright? Go back again. Alright, let me go right again. Pay attention. It's still not complicated. It's free your mind. It's not complicated. Trust me. It's very simple and straightforward. If you remember the first thing, if a question asks to find the equation of a line, as is the case here in question 1, you need to know 2 things about the line that you're going to find. You need to know the gradient, and you need to know a point, because you want to use the BFF formula that we have down here. This formula, you want to be able to use this formula. To use that formula, you must have a gradient and you must have a point. So you can plug the values in that formula. All right? So this question gave us the point. So we don't have to find a point. It gave us the point. But it didn't give us the gradient straight. They told us something that we can use to find the gradient. What did they tell us? They told us that the line that we want is parallel to another line. And once we know that it is parallel to another line, then we know, so all right, parallel lines have the same gradient. So if I can find the gradient of this line, then I have the gradient of the line that I want as well. So how do we get the gradient of this line? We have to put it in the form y equals mx plus c. So when you see the m, you know that is the gradient, and then that's going to be the gradient of the 2 lines, because them parallel. So the sequence of events, it's a sequence of things, and everything logical, flows logically. So the lines parallel, so they have the same gradient. So they give me the equation I want to line them. I can get the gradient from the equation by putting it in the form y equals mx plus c. When I get the gradient, then I know the gradient of the other line as well, because they are parallel. And when I have the gradient and the point of the line that I want, then I can find the equation of the line that I want. To find the equation of a line that you want, you must know 2 things about the line that you want. You must know the gradient of the line that you want, and you must know a point on the line that you want. Sometimes they will give you 2 of them, sometimes they'll only give you 1 of them. In this case, they gave us the point. They didn't give us the gradient, but they gave us information that we can use to find the gradient. The information is that it is parallel to another line. And instead of telling us the gradient of the other line, what they did, they gave us the equation of the other line. Because they know that we can put this equation in the form y equals mx plus c and get the gradient from that. You understand that so far?
Yes, sir.
Good. So you just follow that sequence, right? So let me draw a sketch to make it visual so you can actually see better what is happening. So I'm not going to kind of solve the question, so you can just pure equations in it, but I'm putting a diagram so you can visualize what is happening so it makes better sense to you. All right. So I want to find the equation of this purple line here. I'm going to draw it here. So I want to find the equation of this purple line here. I want to find that equation. That purple line that I want passes through a point to tell me. Passes through a point. Passes through a point. And that point that is passes through is Q. And points of Q is 2, 2, 3. Right, that 2, 3, that 2, 3. All right. I want to find the equation of that purple line right now. Problem though is that I only know a point. I need to also know the gradient if I'm going to find the equation. A point alone can help me. I need a gradient as well. They did not tell me the gradient straight, but they gave me information that I can use to find the gradient. They told me that the line that I want is parallel to another line. I'm going to draw that other line black. And I'm going to call that line 1. Just to reference them. So I'm calling that line 1 that they told me. And they gave me the equation of that line. They told me that that black line is 2y equals x minus 5. So I need to find the gradient. The gradient of line 1, line 2 that I want. I'm going to write it down here. I'm going step by step. The gradient of this line, I need the gradient of this line, line 2. I'm calling this line 2. I need the gradient of line 2. The gradient of line 2 is equal to the gradient of line 1 because they're parallel. So if I can find the gradient of line 1, then I will know the gradient of line 2. They have the same gradient because they're parallel. How can I get the gradient of line 1? Because I can get it from the equation by putting the equation of the line 1 in the form y equals mx plus c. So I go ahead and I divide by the 2, because I don't want 2y as a subject, I want y as a subject. So on line 2, I'm going to put it in form y equals mx plus c by, I'm going to divide by 2, or instead, let me say I multiply by half. You see better that way. Multiply 2 by half. That's what I do with this equation. When I multiply 2 by half, the equation becomes y equals half x minus 5 over 2. So now I know that the gradient of line 1 now is actually equal to half. See there? I'll write it better so you can see. I'm sure you can see the gradient of line 1 is a half from this. See there? Think of line 1 is a half right here, the m. And come back to the purple line now. I now know the gradient of line 2. So therefore, the gradient of line 2 is also a half. So far, so good. Give me time, you know. So far, so good.
Yes, sir.
So in order to have my gradient and my point, then I see can find my equation. Because once you have a gradient,
why you multiply it by a half?
Because I want to get rid of this 2. To get rid of it, multiply by half. Or I can divide by 2. Same difference. To multiply by a half is same as to divide by 2. Alright? Because I want the subject to be y. Remember, I want the subject to be y alone. So I multiply by a half. You good? Or I could have said I divide by 2. Same thing. To divide by 2 or to multiply by a half, basically the same thing. Alright? You cool?
Yes, sir.
Alright, lovely. Alright, so now that we have the gradient, 2 things that we need. We need a gradient and we need a point. We have the 2 of them now. So we can do the equation now. Put them in the BFF formula now. Gradient and the point. So we can say, alright, the equation therefore that we want. The equation of line 2 becomes y minus yq, q is the point that we know, equals the gradient of line 2 into x minus xq. I'll put the values in there now. And so it is y minus yq is 3. So yq right here, the y value of q right there is 3. Equals, the gradient is a half. See there? Gradient is a half. Gradient of the line that we want is a half. Bracket x minus xq. X value of q is this 2. So put 2 right here. And I will simplify this now. Multiply this denominator across here by those 2 and multiply the 1 in there by those 2. That's how we do it when you have a fraction as a gradient, right? So we're going to get 2y minus 6 equals, multiplying the 1, you're going to get x minus 2 inside here. All right, so let me slide this up and go up a little bit now. So what will happen next now is that we're going to transpose the negative 6 and we're going to come positive 6. It's going to be 6 minus 2. All right, we can leave them in order, showing what's going to happen next. All right, so I'm going to get 2y equals x plus 4. Because the 6 minus 2 is plus 4. And then to put it in the form y, I can leave it like this and I'm done. I can do that. But I can also now just put it in the form y equals mx plus c. Again, by dividing by the 2 or multiply by half, similar to what we did up here. Right? So any way you want to look at it, I'm going to get y equals half x plus 2. So the 2 lines parallel, now look at the 2 lines parallel. 2 lines, look at the 2 equations. 2 lines have the same gradient, half. What is different is the y-axis intercept. See, I got the y-axis at 2 different places. I'm not showing the x-axis and the y-axis in the diagram, but that is what will happen. They have 2 different y-axis intercept, but they have the same gradient because they're parallel. So far, so good. Very good so far?
Yes, sir.
Yes, sir.
All right, good. Now watch me now. So that is question 1. That's the answer for question 1. This is the gradient. This is the answer right here. This is the answer right here. For question 1. So finish question 1. That is question 1. Done. Let's go on to question 2 now. All right, let's go on to question 2. And trust me, this thing is very easy. Looking at question 2 now. All right, let's go on another page for question 2. Question 2. All right. Question 2 says, find the equation of a line. See, there is asking us for the equation of a line right here again. Now, once a question tells you to find the equation of a line, you need to know 2 things about the line that it's telling you to find. To find the equation of a line, you need to know 2 things about that line. You need to know the gradient of that line. I need to know a point on that line. All right. What did they tell us? They told us that it is perpendicular now. So treat that as a different question now. Now they're using the word perpendicular. So this perpendicular is to help us to find a gradient. It is perpendicular to this other line. So it means that the line that we want have a perpendicular gradient to this one. Or you calculate a perpendicular gradient. Flip the one that you have and change the sign. So we apply what we just learned to know. How you go from one gradient to the next is then perpendicular. Or you go from one gradient to the next is then parallel. To go from one gradient to the next, if the 2 lines parallel, you just make them equal. To go from one gradient to the next, if the line is perpendicular, you flip the one that you have and change the sign. And that is going to be the gradient of the other line, which is perpendicular. All right, and they give us the point that it passes through. See there? So this question, they give us the point, they give us one of the things, but they don't give us the gradient. But they give us information for us to use to find the gradient. What information is that? That information is that it is perpendicular. The information they gave us to find the gradient is this right here. This, that it is perpendicular to this. That's us first to find the gradient. Gradient M that we want. All right? So let's go and do it now. Pay attention. I'm going to step by step. Don't wait till I finish and then you tell me, say, you don't understand now. Any step you don't understand, you tell me. All right? Let's go. It's very similar to the other one. The only difference is that you're working with a perpendicular line. That's the only difference. But let me go and do it now. So I'm gonna draw the line that we want now in red. All right? So we want a line that is red. So I'm going to draw about the black line first, because I'm saying perpendicular to the black line. So I'm going to draw about the black line first. So this is my black line. That's my black line. And if you have that black line, they told us if you have that black line is the same 2y equals x minus 5. And so the gradient of the black lines are half just the same. So it's y equals half x minus 5 over 2. All right? So this was this original same line 1 that we had in the first question a while ago. Line 1. Same line 1. All right? So the gradient again is the half. So the gradient of line 1 is a half. You can see it there. Now, they want another line, so I'm going to draw in red, which is perpendicular now to that one. So I want a line now, perpendicular. So that line that we want now is going to go like this. Perpendicular, see? That symbol for perpendicular. Cross each other at right angles right there. Right? The perpendicular. All right, and this line that we want, they tell us it passes through a point Q. Passes through a point Q. And Q has the same coordinates, 2, 3. So this got the same point, but this time now we're working a perpendicular line now. And this line we're calling it line 2. Let's put that 2 up here for line 2. Right? So, no, not 2. This is now line 3. The line 2 already. We're line 3 now. Line 3. Line 3. All right. So, what do we know? Because them perpendicular, so if you know the gradient of line 3, no, start back. To find the gradient of this red line right here, I need to know 2 things about it. I need to know the gradient and a point. I know the point already. I don't know the gradient. But they gave me information to find the gradient. What information they gave me? They told me that it is perpendicular to this black line. I will know the relationship between perpendicular lines is that gradient of perpendicular lines are negative reciprocal one to the next. So the gradient of this line, which I'm going to call line 3, gradient of line 3 is going to be equal to -1 over the gradient of line 1. Right? Gradient of line 3 is -1 over the gradient of line 1. But understand that so far? Because they are perpendicular. But understand that so far? Don't want to move on until you understand that so far. But go so far?
Yes, sir.
Good.
Yes, sir.
And how
Sir.
do we?
Can go back.
Huh?
Sir, do you flip it or do you
Yes.
put as a denominator and put 1 over it?
Flip this one and change the sign. I get the next gradient. Simple.
Okay.
This calculation right here is flip and change the sign of this. That's all you have to do. Flip and change the sign. That's what that is. Flip it and change the sign. Right? So the gradient of line 3 becomes, if you flip this and change the sign, what am I going to get? Flip a half and change the sign, what am I going to get?
-2.
-2. Very good. This calculation, this calculation right here is the flip business. Flip and change the sign. I'm not going to write out everything. That's what we flip and change sign. Flip, change, sign. Or flip the one that we have and change the sign to get -2. Because you flip this half, it's going to become 2 over 1 and change the sign to negative. -2 over 1 is the same as -2. All right, that's why it becomes -2. All right, so the gradient that we want right here is -2. That's the gradient. So now that I have two things that I want, I have the gradient of the line that I want, the red line, and also the point. I can now find the equation of line 3, that perpendicular line. I'm going to do it in red, just the same. All right, so I can now get the equation now. Now that I have the thing that I want, I can get the equation. So the equation now, see here, let's put on the equation of line 3, that perpendicular line the question wants us to find, is y minus yq equals the gradient of line 3 into x minus xq. That's the gradient, that's the equation, you know. All right? Still point q we're using, but it passes through the point q. So let's put in the values again. So it's y minus yq is this value here, the 3. So y minus 3 equals the gradient is -2. That's a perpendicular gradient, -2. -2 bracket. And then it's x minus xq is 2 right there. So that is 2. And you just expand this bracket because the gradient is not a fraction. So let's expand this bracket and I get y minus 3 equals minus 2x plus 4. Right? And then I need to transpose this -3 over here and add it to the 4. So I'm going to get 7. So I'm going to get y equals minus 2x plus 7. And this is my answer. The perpendicular line that I want. Trust me, it's easy. It's not difficult. You just need to practice. So this is when I tell you to, for example, to go home and work over the example that we did in the class, something like this. You go home and you do these calculations over again by yourself. That's what you're supposed to do. Work these calculations over again by yourself. That is how you master it. No matter how many times I do it, you know, I always look easier, because I'm explaining what I'm doing. But you now have to go and do it yourself so it becomes easy for you. And you have my working out, you have my solution, Just work it. If you have to work it 3-4 times until you get it, you do that. It's not difficult. It follows a logical sequence. Right? What are the things involved? One, if you want to find the equation of a line, you need to know two things. Gradient at a point. So if they give it a gradient and they give it a point, good enough to work out none. But sometimes they won't give you all information straight. They give you some of the information and then they give you information that you can use to find what you want. In these examples, they gave us a point. So in none of the two lines that we want, we did not have to go looking for a point. They gave us the point straight. But then they didn't give us the gradient straight. They wanted us to apply our knowledge of perpendicular lines. Right? They wanted us to apply the knowledge of perpendicular lines and parallel lines. Our knowledge of perpendicular lines is that they have the same gradient. Our knowledge of our knowledge of parallel lines is that they have the same gradient. Our knowledge of perpendicular lines is that they have negative reciprocal gradient. Furthermore, they wanted to know if we know how to get the gradient from the equation of the line. I will get the gradient from the equation by putting the equation in the form y equals mx plus c. So this question testing a number of things in a simple worded question like that. Two line, one straight question, and it testing a number of things. Right? And it follows a logical sequence. And it's all very easy. All right? So let us move on. We just need to go on. Yes?
What if they didn't give us the point and only gave us the gradient?
Then they would have to give you information to find the point, right? They would have to tell you something that you can use to find the point. As simple as that. And you will see examples like that, where you have to find the point. Right? And we see examples where they have to tell you something that can help you to find the point. It's usually very simple. But they have to give you information that you can use. They can't give you a question and there's no information for you to use. Information must be there that you will use. So they give you the gradient alone and they don't give you a point, they have to give you something else for you to use to find the point. They give you the point, they don't give you the gradient, they have to give you something that you can use to find the gradient. And you have to know all these relationships where gradient is concerned. Right? So we're learning. So, don't worry yourself, these things will become very easy for you after you start practicing questions and the language and the wording and stuff. Once you start practicing questions and stuff, they'll become very easy and straightforward. All right, so if you don't get it 100%, or probably in the other video, go back and watch the video later and stuff like that. And it will all become clear soon. All right, but let us move on. I want to finish the notes today so that we can do a question or two. Right, you can always go back and watch these things. All right. It comes down to what you do, what you actually do in terms of solving questions. That's where you get a full understanding. No matter how many times I do it on the board, or do it here for you, no matter how many times, you still have to go and do it for yourself. All right, that's how it goes. You have to do it for yourself, guys. All right, so let's move on. All right, I'm gonna skip over this perpendicular bisector line. When we master it a little bit more, I will deal with this. All right, this is another question that has a number of things in it. So I'm gonna come back to this after do some other stuff and improve on it. Then I'll come back to this one, perpendicular bisector line. All right, so let me not fuss too much about it. I'll explain it some other time a little bit better. Simple still, but I don't want to focus on this right now. All right, it's a line that passes through the midpoint and is also perpendicular to a line that you have. All right, so I can do a number of things. But we'll do these examples some other time. All right, so don't worry. So, point of intersection of two lines. Find the point of intersection of two lines. You have to solve the two equations simultaneously. I'm also not going to do simultaneous equations as if I'm teaching. You have to solve them simultaneously to find where they meet. If there's a line and a curve, we did this already. We did quadratics. solving simultaneous equation of a line and a curve. It was a substitute the line into the curve, right, and get 2 points. All right, so that's where you find points of intersection. You solve the equations simultaneously. All right, so you have to be able to do that. All right, we do some of these already. All right, we will do some of these later on. And in fact, we're going to do a question where we have to do some of this. All right, so don't worry yourself. All right, this is one of the last slides, and it's a skill that I want you to recognize. How do you draw the graph of a line? How do you draw the graph of a line, of a straight line? All right, so there are two ways really, but there is a way. Second of the two ways is what you're not gonna see in a lot of places. I don't know if any teacher actually teach that other way. All right, so it's something that is very easy and very useful, but not a lot of people will actually show students that other way. Right, so let me just go through it. All right, so there are two ways, right? One way is to use 2 points. So they give the equation of a line. You can find any 2 points using the equation and find any 2 points. And then you draw the graph through those 2 points. All right. So draw the line. To draw the line on a graph, you can find 2 points on the line, and you want them to be a reasonable distance apart. You don't want them too close to each other, because the closer they are together, the more inaccurate or it's kind of likely that you might go a little bit off. Right? So you want to put the lines far apart on the graph. All right, and then you draw a straight line through the 2 points. So there's an example here. So look at this example. Let's say I want to draw the line. I draw that line, 5y equals 3x plus 2, and I want to draw it on this graph over here. Right? I want to draw it on this grid over here that I'm seeing. And I'm saying what you can do, you can find 2 points, and I just choose these 2 points randomly in this example. There's no special reason why I chose these 2 points. So let me say that up front. So it's any 2 points that you want to use. And how do you find 2 points? You can give the equation an x value. Put an x value in the equation, and the equation will tell you what the corresponding y value is. Like this. So I choose 6 randomly. So I'm choosing 6. Just randomly for no particular reason. I choose 6. I just want 2 values that are far apart. Right? I could have used 8. So I choose x equals 6. And what I do? Plug the 6 in the equation to see what the corresponding y value is. See? Plug the 6 right here. Plug the 6 right here. And then the equation will tell me what the corresponding y value is. Now when I plug the 6 right there, I end up getting the 5y equals 3 times 6 is 18 plus 2 is 20. So 5y equals 20. And then naturally I'm going to divide by 4. So we divide by 4. I divide by 4. I'm going to get y equals 4. So when x is 3, when x is 6, sorry, y is 4. You can see that right here. So it means that there's a 0.64 on this line. There's a 0.64 on that line. That's what it means. All right. So that's it. 1 point is 64. And I can show that point on the graph. But see the 0.64 on the graph there? See here? That's a 0.64
Yes,
on the
sir.
graph. Then now I want another point. And I want it far away from that 0.64. So all I have to do is give x and put x, another random x value in the equation and see what the y value is. The equation will tell me what the corresponding y value is. So see there, bam. I put in x equals -4. See, I'm going all the way far as possible from the 6. I don't want them too close. So 6 is here. I want another point all the way over there. So I put in our x value of -4. And then put the -4 in the equation right here. I get this. All right, and that works out to 5y equals -10. Then no, if 5y equals -10, then y equals -2. So what that means is that the point -4, -2 is a point on this line. All right, is a point on that line. So that is a second point, -4, -2, and then I can just mark it on the graph. right there. But I see the point, -4, -2 on the graph now. But I see the point.
Yes, sir.
And once you have the point on the graph, all you have to do is use a ruler and draw the straight line through those 2 points, like that. And that is a straight line. All right, and then what you can do now is just maybe label the line. 5y equals 3x plus 2. That's the line, 5y equals 3x plus 2. That's method 1, but I feel it's too much work. You don't need to do so much work. All right, and it's a different method, and that is using 2 points. Other method is one that I like a lot, using 1 point and the gradient. Now let me tell you how that works. I can demonstrate it over here before we start. Or if you have a line, right? Let me show you. If you have a line, and you know 1 point. So 1 point, say 1 point, and 1 point is 3, 4, for example. And let's say the gradient of that line is 2 over 3. 2 over 3 is rise over run. It means that rise over run is 2 over 3. So it means that from this point to get to other points on the line, you can rise 2, and run 3 to get to other points on the line, right? So let me show you. So let's say this is a graph, and I have a point right here. Let's say the point right here is 3, 4. Let's randomly pick out that point, 3, 4. And I want to get to other points on the line where the gradient is a half, is 2, is 3 over 2. It means that from that point, I can rise 3 units and rise 2 units and run 3 units. So from here, I can rise 2 units. 1, 1, 2. And then run 3 units. 1, 2, 3. So what it means is that this will be another point on that line that I want. Simple as that. I can continue. Rise 2 again from this one. 1, 2, and then run 3. 1, 2, 3. So you see that now is another point on the same line. Right here. And you see that you can now draw a straight line through them. Like that. It's not so straight, but you get the picture. So like that. Using 1 point and the gradient. So you rise and run from 1 point. Rise and run from 1 point. 1 point that you have. Now, suppose for argument's sake, the gradient was negative instead of positive.
Sir. Could you go over that again, sir, for me, please? I didn't get it.
Didn't get it. All I'm
Sir,
saying
so your
is
rise and run is a gradient.
There's a question. Sir, them always gonna give you the gradient.
Listen, not no. They don't always give you anything. What you do in maths all depends on what you're given. I'm just showing you another way that if you have the gradient and 1 point, you can still draw the line. It's a very, very powerful way to draw a line. If you understand that gradient is how you rise and run from 1 point on the line to another point on the line. That's what gradient is. Gradient is a measure of how much you have to rise and run from 1 point on a line to another point on a line. So if I am at 1 point on a line, and I need to get to another point on the same line, I can use the gradient to get to other points on the line. Gradient is just rising and running from a point to get to another point. Then you rise and run again to get to another point. Then you rise and run again to get to another point. And that's how you can get to points on the line using the gradient. This is all I'm saying. Right? So if the gradient, for this example again, if I know, let me undo everything. Let me erase everything and start again. And okay, we can do everything 2 and 3 times. I never finish a class. Right? It's not difficult. Just open your minds. Right? All I'm saying is that I can draw this line. I can draw the line. I can draw the line that passes through this point and has this gradient. And I can draw that line. I can draw the line that passes through that point and that also has a gradient of 2 over 3. So 2 over 3 means rise to run 3. Because gradient is rise over running. So it means rise to run 3. So all I need to do is put on the point that I know first, right here. And then I'm going to get to other points. I'm going to rise to run 3. So let me use the arrows instead. 1, 1, 2. So I'm rising 2 units. And I'm going to run 3. 1, 2, 3. 1, 2, 3. What it means is that there's another point on the line right here. Right here, that's another point on the line. Right? Because I rise to and run 3 from the first point, and that's another point on the line. And from that point, I can also rise and run again to get to yet another point on the line. Here, rise to 1, 2, here, 1, 2. Rise to run 3. 1, 2, 3. 1, 2, 3. And if you have a time graph, it's quite easy. And so there's yet, hold on now. So there's yet another point on the line right here. So I've used 1 point. I've used 1 point and the gradient to locate points on this line. You understand that? Let me show you something magical now. Watch this. I'll show you something magical now. Watch this. Watch this. Now, the same gradient, which is 2 over 3. The same gradient, which is 2 over 3. It's the same as 4 over 6. Don't it? So instead of making those little mini rise and those mini runs, I can make a big rise of 4 and a big run of 6. So watch it now. Let's use a different color. I'll show you kind of the same place. So instead of rising 2, running 3, and then rising 2 again, running 3, I'm now going to rise 4. Look. 1, 2, here, 3, 4. So I rise, raise a 4, rise 4. I'm going to run 6 now. 1, 2, 3, 4, 5, 6. I end up at that point anyway. So I can make a big jump and leave out this one. I didn't have to put in that one. If I just make a big jump like that, it is still the same line. The points are on. There. Same line. I'll show you something that is even more magical now. Watch this now. Watch this now. Show you something more magical. Alright? Watch this now. I can go in the opposite direction as well. Watch this. Alright? Watch this now. I'll undo the line and show you something. Now, and let me use a green for this one now. Green. So just use that green. The same gradient. But you can see that it's 2 over 3. Now 2 over 3 is the same as negative 2 over negative 3. This is still rise over run. But you can see that. But you can see that. And I don't. You can see it.
Yes, sir.
This time I'm gonna rise negative 2, go negative 3. You're the magic about it now. When my rise is negative, I go down. And when my run is negative, I go to the left. So when my rise is positive, I go up. And when my run is positive, I go to the right. But when my rise is negative, I go down. And when my run is negative, I go to the left. So I can find 8 points on the same line with this gradient. Instead of going up, and to the right, I can now go down and to the left. I'm still going to get points on the line. Watch this, watch this. 1, 2, and then 1, 2, 3. So I'm saying that there's yet another point here. See, still in the same line. Everything line up same line. You can see. It's a magic of gradient and a point. Alright, so when you have the gradient and you have a point, you can draw a line using those two. And if you understand that that's what gradient is just how you rise and run from one point to another point. I can make some little rise, some small rise, and some small runs. I can make some big rise and some big runs. So you can use values. Once you're using values that equal the same thing. So for example, I have 2 over 3. 2 over 3 is the same as 6 over 9. Same as 6 over 9. You understand? And it's the same as negative 6 over negative 9. So this one will take me up and across, up 6 and across 9, up 6 and across 9 from one point to get to another point up here. But this one, if I start here, it's going to take me down 6 and back 9, down 6 and back 9. This way, you have to get to another point, and I can draw my line like that. And this one, I draw my line like that. So that's the power of gradient. Right? Gradient, so remember, gradient is rise over run from one point to another point. And that's what this slide is about. All right, so let's look at it. So this slide didn't work already, so we're supposed to go through this fast. So use the gradient to rise and run from a known point. So you have to rise and run from a point where you know already. Right? And a known point, if you have the equation, is always the y-axis intercept. Remember now, when you have the equation, you can know the y-axis intercept by putting the equation in the form y equals mx plus c. So if I give an equation, put it in the form of y equals mx plus c, it means that a point that I know is on the y-axis, 0, c. So all I have to do is use that point and then use the gradient to rise and run from this point to get to other points. All right, that's what you can do. All right, so let's look at it. So remember, if the rise is positive, you go up. If the rise is negative, you go down. If the run is positive, you go to the right. If the run is negative, you go to the left. All right, I just demonstrated that over there on the right side of the page. So let's do this example now. I want to draw that line, but I'm not going to plot 2 points now. I'm going to use the gradient and a point. Now, to get the y-axis intercept, right? To get the y-axis intercept, I need to get rid of the 4. So I'm going to divide 2 by 4. All right? I'm going to divide 2 by 4. If I divide 2 by 4, I get that. What does that mean? It means that this is my gradient. This is my gradient, meaning rise negative 5, run 4. But it also means that this 6 means that I know a point 0, 6 is on the line. That's my y-axis intercept. So from this point 0, 6, I can, from the point 0, 6, this is the point 0, 6, I can rise negative 5, go down 5, and run 4. So this will be negative 5, this will be 4, and get to another point and draw that line like that. Simple as that. But let's do it. All right, so let's look back on the slide now. It means, therefore, that my rise over run is negative 5 over 4. So from the y-axis intercept, I can rise negative 5, meaning go down 5, and run 4, means go to the right 4. But I need to do it from one point. One point, as I said, on that line would be the y-axis intercept. So you don't have to, the beauty about this method, you don't have to waste time calculating anything. The y-axis intercept is 6. You know that. And the gradient is -5 or 4. You don't have to waste time calculating points. Just start at the y-axis intercept, and then to get to other points, you rise -5, run 4. Bam. See there? Rise -5, run 4. So let me demonstrate it on the slide right here. Let me demonstrate it for you on the slide, what I would do. I can do the run first, and no matter what, I can do the run first. I can run 4, rise -5, right? But let me do it on the slide. Let me use a blue ink to do it on the slide right here. Watch this. So, see, you know, this right here is the point that I know my y-axis intercept. So to get to another point on that line, I don't have to calculate anything. I rise 5 down, go down 5 units. So 1, 2, 3, 4, 5 until to this point right here. Good? And then I'm going to run 4. Look, 1, 2, 3, 4, get to this point right here. So what I've done, I've rise 5 down and run 4 to the right. Let me draw it. So down 4, no, down 5, sorry. That's -5, run 4. And that this point is on the line. So my line will go like this. Draw that down. Erase that thing. Draw it down. That's my line. I never calculate no point. Put on the y-axis intercept, and I use the gradient to rise and run from one point to the next. And watch this. I can rise 5 and run, rise -5 and run 6 again from here. Look, 1, and I rise and run again. Let me use a different color to rise and run so you can see it. Right? 1, 2, 3, 4, 5. Run 4 now. 1, 2, 3, 4. So that's another point on the line. So the line at there, you can see it. The line is passing through that as well. See there? That's it. So I can draw the line easily. Rise and run. So that's a -5. Come down 5. And I went across 4. Run 4. Easy. And this just need practice, guys. Alright? Well, let me show how it is done on the slide. I can do the run first too. Now let me show you if I do the run first. Watch this again. End up at the same point. Right? If I do the run first, I'm gonna get the same thing. Watch this now. And let me use the red. So starting at the y-axis intercept at 6. 6 is my y-axis intercept. Let's use the red. I'm gonna run first. I'm gonna run 4. 1, 2, 3, 4. I'm gonna rise -5. Mean go down 5. 1, 2, 3, 4, 5. See? I get back to the same point right here. I'm gonna run 4 again. And do the run first. It doesn't matter. Just know that you're running and you're rising. So I run 4 and right. So I run 4, rise -5 to get to that other point down here. And I can rise and run again. Look, run 4 again now. And run 4 again. I'm here. 1, 2, 3, 4. Get to there. Alright? And then rise -5. 1, 2, 3, 4, 5. So I get back to the same exact point that I had when I did the rise first. And the same lines there. One straight line. That's it. That's my line. I have drawn this line that we using the gradient. That is a line that I've drawn using the gradient and a point. I didn't have to calculate anything. Put it in the standard form so I can see the y-axis intercept. I use the y-axis intercept as my known point. And then from the y-axis intercept, which is a known point, I just rise and run to get other points in the line. Rise and run up to the other points. Simple as that. Right? And you have to Pay attention to these things. You're not gonna see these things in a lot of other classes, I promise you. Most people are going to teach you how to use the 2 points thing, which is more work, right? So see here now, put on the point. I'm doing it on the slide now. Put on the point, y-axis intercept. And this I think I did the run first. See there? Run 4, rise -5. And that takes me that other point on the graph. And then because I have that other point, I can draw my line. Easy as that. I don't calculate nothing. And I label my line. Done. So I prefer method 2. If you have the equation, and you want to get, just put it in the form y equals mx plus c. So you can see the y-axis intercept and see the gradient. Mark down the y-axis intercept and then look at the gradient and just rise and run the way you want. Rise and run the points that you want. Simple as that. Let me show you something again that is kind of magical. Watch this. Let me show you something quick. All right. Let me show you something. Let's teach you everything. So we're teaching you everything. Watch this now. No, see this, see this, see this, see this -5/4. That -5/4 really no, is the same still as 5 over -4. No? It equal the same thing. No? If you were to calculate it, it equal the same thing. That's like I multiply numerator and denominator by 1. So this now is saying rise 5 and run -4. You're gonna be on the same line, guys. So if I start at this point down here, which I know this was a point down here, right? This was a green for the rise and the run. Watch. If I rise 5 and run -4, I'm still gonna get back to points on the line. Watch. Rise 5. 1, 2, 3, 4, 5. Run -4 now. 1, 2, 3, 4. -4 means I go back. +5 means I go up. See, I get back at that point. The same thing again. I can rise 5. Naturally, rise 5 when I get back up here. And run -4 when I take me back to that point. So if you're going, if you even go in the opposite direction with the gradient, you're still ending up at points on the same line. Doesn't matter. Very good.
Yes, sir.
Yes, sir.
Yes, Dad.
So these things only need to practice, right? All right, so we're finishing off now, and then we're gonna do a question. What time is it? What time is it? I want us to do a nice question before we finish. All right. Let's finish the 5. So not too much, not too bad. All right, watch this now. Equation to form. We're gonna have to use the equation. The next topic. In fact, the next topic is a nice topic called linear programming, linear inequalities, and linear programming. Very nice topic. We're using a lot of coordinate geometry and the equation of lines and all these things. But instead of putting the lines now, we put in the inequality. Right? We're doing linear inequality and linear programming in the next class. All right, that's section 2 topic. We're gonna have a lot of fun. And we're gonna have to be drawing a lot of vertical lines and horizontal lines. So I'm just putting these slides for you to recognize this. Vertical lines are of the form y equals a number. Remember when we did coordinate geometry, I want to say the axis of symmetry. But the axis of symmetry was always vertical. When we did coordinate geometry, the axis of symmetry was always vertical and it was always x equals something, not the x but like maybe a quarter. Remember? Because it's a vertical line. Vertical lines will always be x equals a number. And horizontal line will always be y equals a number, like y equals 5. Let's look at this on the slide.
You mean quadratics and not coordinate geometry?
Yeah, when I did quadratics, not quadratic, we did quadratics and we had the quadratic curve like that. And we did the axis of symmetry. The equation of axis of symmetry was x equals something, like x equals 2 or 4. That is because a vertical line will always have an equation, x equals a number. Alright? In fact, I can tell you right now, the y-axis and the x-axis are your first two vertical lines. You see your x-axis, the equation of x-axis is actually y equals 0 now. And the equation of your y-axis is actually x equals 0 now. Those are the equations of those lines. Right? Y equals 0 is the equation of the y-axis. This is the y-axis. Y-axis. And this down here is your x-axis. We have equations. This is the equation of the x-axis. And sometimes 6 you'll do that, you know. Sometimes 6 you'll say something like, find the point of intersection of the curve with the line y equals 0. You have to know that the line y equals 0 is actually the x-axis. Right? You have to know that. Right? So that is that. So let's continue. All right. So that's what this slide is saying. The equation of the y-axis, you start with it, is x equals 0. So any line that is vertical like the y-axis is x equals a number. Right? Graph of the form x equals a is a straight line parallel to the y-axis. And x equals 2.5 is a vertical line passing through 2.5. Okay, I'll show it. So if you look at the graph right here, now look at the scalar graph carefully. You know. Look at the, don't just run and draw anything. You know. Look at the scalar graph first. So this is 2. And this is 4. Then right here must be 3. And therefore 2.5 must be right here, right? Between them. Alright? So therefore, the line x equals 2.5 is that line right here. But understand that? Let's do another one. X equals -3. So x equals -3 has to be that line right there. But I can see it. Next example. X equals 7. X equals 7 is a vertical line passing through 7. So see there, that's x equals 7. So those are your examples of your vertical lines. Cool? Let's look at another example. Let's look at horizontal lines now. Horizontal lines will always have an equation of the form y equals b, y equals some number. Horizontal lines will always have an equation y equals a number. All right, so first horizontal line is the x-axis. The equation of x-axis is y equals 0. You can see it right there. The equation of x-axis is y equals 0. So any line that is horizontal and parallel to the x-axis will be y equals some number. All right, that's it. A graph of the form y equals b is a straight line parallel to the x-axis and cutting the y-axis at b. So for example, if you want the line y equals 2.5, then it's the horizontal line passing through 2.5. And again, what we have to do, this is 2, this is 3, so 2.5 is right between there, at 2.5. So we can draw that, right? See there, y equals 2.5 with that horizontal line there. Next line, y equals -3 is a horizontal line passing through -3. That's it, y equals -3. And then y equals 5 is a horizontal line passing through 5. That's it right there. So this is information that will be very useful in the next topic, which is linear programming and linear inequalities. You'll have to draw a lot of horizontal lines and vertical lines. You have to write the equation of the lines on them. You have to label them. So remember, vertical lines are x equals a number. Horizontal lines are y equals a number. And you can remember that by remembering that the x-axis is y equals 0. And it is not difficult to know that the x-axis is y equals 0. I'm sure. Why is it y equals 0? Because at all points on the x-axis, the y value is 0. All of these points on the x-axis, y value is 0. That's why the equation is y equals 0. And then for the y-axis, which is the line x equals 0, all points on the y-axis, the x value is 0. That's why the equation is x equals 0. All right, it's not complicated, trust me. All right, it's not complicated, simple. So basically, you're doing these questions. So let me show you those questions over here now. What you're doing. Let me show you. Let me show you. Where is it? All right. So what I want us to do one of these questions before we finish today. All right. Well, these questions are I don't like to use the word difficult when it comes to maths, right? Mathematics always is easy. But these questions requires more work, let's put it that way, than a question that you will get in CSEC. So if you can do and understand one of these questions, then you'll be able to answer those little baby questions that you get in CSEC. Right? We're gonna do some of those baby questions on Wednesday before I give you the classwork. Right? There's another one up here as a perpendicular bisector. So we can do this one as on Wednesday, the perpendicular bisector. But then no, there's also the handout, right? There's also the homework, which is this. So let's do that. So making this answer. All right. So you basically want to be doing these questions, guys. All right. So you want to be doing these questions for homework. And everybody's supposed to have these once you have the handout. All right. I want to try these questions. These are all corner geometry questions. So nice easy one here. Down here. I gave you 2 points. All right. Gave you 2 points. And that's this one down here. So they gave you 2 points. And I wanted to find a gradient and the equation. Easy, right? Gradient is just difference in y over difference in x. And when you have the gradient, you can use the a or the b to find the equation. Y minus ya equals m into x minus xa, for example. This one down here. So to the left a line passing through those 2 points again. And I want to find a gradient, and I want the equation, and I want the midpoint. Remember, midpoint is just the average. And then I want the length. But the length now is the square root business, square of the difference in x squared plus the difference in y squared. So back at all those things. Look at this one here right now. Look at this one. This one is one where they give you that point, and they want you to draw the. They want us to draw the. Oh Lord. They want us to draw the curve, draw the line, and they tell you the gradient is -3/2. And I wanted to draw the line. All right. So from that point P, you can write -3, run 2 to get another point. Right. I want to try those things. All right. This one up here again is another easy one. They give you the point and they give you the gradient. And I wanted to get the equation. And when you get to the equation, you must put the form y equals mx plus c. But you can still start with the BFF formula. Right? Y minus yp equals m into x minus xp. Right, and they talk part 2 now, so sure is this parallel to this line. Remember, them parallel, them have the same gradient, right? Parallel lines have the same gradient. You have this question over here. So we're going to do some of these questions on Wednesday. I want you to try them first. All right, you have this question over here as well. All right, and you have this one down here. This is the example that I'll show you where if you want, you can use a point that you don't know. So for example, you can use a point E. Here's a point E now, because E is in the middle of nowhere. What you can do is use instead the point 2, 2. And see that the line passes through the point 2, 2 on that graph. So you can use the point F, because F is a point 5, 0, and you can use the point 2, 2 to work with that. You can use the point E, because E is a point in the middle of nowhere. All right, so I'm going to try those questions, but I'm going to do one question for you before we finish today, because more maths equals better maths, you know. want us to do this question right here. This question, so let's set it up. I want us to do this question in the middle right there. All right, I want us to do that question. I think I have to close this out first. That over there, and then over here I start note. All right, and I can go back. Start a new one. All right. So I want us to do this question on the left, right? Everybody can see it? Everybody can see that, right?
Yes, sir.
All right, good. Okay. Let's read it out. Can I mark on this? Okay, I mark on it. Let me take a mark on it. Show me to something that I can mark with, you know. All right. Okay, mark on it, mark on it with this. But when I move it, it's gonna go. So you can mark on it and see if I can come up. Okay, so I can work there, no problem. I have to keep that on the page. Undo. All right. All right, so I'll keep this down here and see if we can work it. All right, cool. All right, so question there, what I want to do. So after this, gotta be able to fit everything right on this page right here. It's kind of difficult to do. All right, okay, work still. We work out something. All right, so this question says, in the diagram below, A is a point -1, 3. You can see that A is a point -1, 3, and B is a point 3, 1. It says L1 passes through the point A and is parallel to OB. So what they didn't show us was the line OB. So let me draw it on the diagram. And I'm going to use, yeah, let's use the same blue. Let's use the same blue to draw it on the diagram. So they didn't show us the line OB. That's it. And they told us that these two lines parallel. This line and this line parallel. What does that mean? It's a parallel. I'm putting the arrow to mean that the parallel. What happens if they are parallel? What happens if the lines are parallel?
The same gradient. Too.
They have the same gradient. Very good. All right. So we know that. So that information is going to become relevant, right? And then now, what is it? They said the line L2. So look at L2 now. L2 passes through B, and these are 0.31, and L2 now is perpendicular to AB. It is perpendicular to AB. So what does that mean now? If they are perpendicular, and we can see it right here, the perpendicular right here. So these two lines are perpendicular. What does that mean if they're perpendicular? Then what do you mean? This line and this line perpendicular. What's the relationship between them? Those two lines if they're perpendicular.
They have something
Negative reciprocal gradient. Cool. I know you just learn it. You just learn it to do. So no worries if you're not saying it. You soon fly off the tongue like if I learn it. Don't worry. So they have negative reciprocal gradient. So to find the gradient, you can flip the one that we know and change the sign. Now look at the question now. It says line 1 and line 2 meet at C right here. So C is the point of intersection of line 1 and line 2 right here. Good. And they want us to find that point C. That's the question now. So with all of that information, all they want us to do is find the point C. They want us to find the coordinates of the point C. That's what they want us to do in that question. Let's mark it, the point C. So let's reason it out. All right, I'm going to help you. I want you to think steadily, but I'm going to help you. All right. What do we know about point C? C is the point of intersection of the line L1 and L2, don't it? So under normal circumstances, how could we find point C from L1 and L2. What would we need to know about L1 and L2 if we want to find the point C? Somebody can tell me? Anybody? What if I know the equation of line 1 and I also know the equation of line 2? How could I find the point C? If I know the two equations, line 1 and line 2. Nobody can tell me. Remember, the point of intersection of two lines. If you want to find the point of intersection of two lines, then you just solve the two equations simultaneously. Right? You solve the two equations simultaneously, simultaneous equations. Solve them simultaneously. Solve the two equations simultaneously. Because at that point satisfies this line and it also satisfies that line. So to find the point of intersection of two lines, you solve them simultaneously. All right, so we know that we need to solve these two lines simultaneously, L1 and L2. So therefore, we need the equation of this line. And we also need the equation of this line. So we need the two equations. So let's talk about line 1 first. To find the equation of line 1, we need to know two things about line 1. We need a gradient, and we also need a point. We have a point already, so we don't have the gradient. But they told us something that we can use to find the gradient. They told us that it is parallel to this line down here. That's what they told us now. And parallel lines have the same gradient. Remember that this line point down here is 0, 0. The origin is 0, 0. Right? And then this point right here is 3, 1. So it means to go from this point to this point, you run 3, rise 1. So the rise is 1 and the run is 3. So that gradient of this line down here is simply rise 1, run 3. That's it, as easy as that. Very easy, you know? Trust me, it's very easy. Right? I don't want to erase everything. All right, let's talk about line 2 now. For line 2, we want the equation. We need to know two things about line 2. We need a gradient and a point. They gave us the point right here. What did they tell us? They tell us that it is perpendicular to this line. And because we have these two endpoints on this line, we can actually find the gradient of this line. And we'll find the gradient of that line. We're going to flip it and change the sign, and that's going to give us the gradient of line 2. And then when you have the two equations, this one and this one, we solve them simultaneously. All right, so let me erase everything and let's draw back what we had. So what we had was this point, this line is parallel to this line. That's what we had. And then this is the point of intersection of the two lines. All right, that's what we had. All right, so I won't be able to leave this on the diagram because if I move this, it's gonna go. All right, it's gonna go. So imagine that is on the diagram. If I move that, it's gonna go. You're not gonna see it. All right, but let me do the working over here though. All right. All right. So we're gonna try to find the two equations. So we say C at C. Let's do it at C. Oh man, a mistake. All right. So we say at C. Let me not start it that way. Let's say we realize that we need the two equations. So we need the equation of line 1. Let's work on line 1 first. So the point on line 1 that we know, line 1. The point on line 1 that we know a point already. The point on line 1 is point A, which is -1, 3. We don't know the gradient. All right, but we know that line 1 is parallel. That's what that symbol there means. It means parallel. This means line 1 is parallel to OB. That's what the question told us. So because line 1 is parallel to OB, it means that line 1 has the same gradient as OB. So we can do it right here. Gradient of line 1 is equal to the gradient of OB. Where, so that means where, we're going to work out the gradient of OB now. Because OB passes to the point O and B. OB passes to the point O, which is 0, 0, and B, which is 3, 1. Then the gradient of OB is the difference in y by difference in x. So it is 1 minus 0, which is 1, over 3 minus 0, which is 3. The gradient of OB is 1 over 3. Therefore, gradient of line 1 is also 1 over 3. So because we have the gradient of line 1 and we also have a point on line 1, we can find the equation of line 1. So the equation of line 1 is y minus ya equals the gradient of line 1 into x minus xa. That's going to give us the equation of line 1. All right, let me put it on right here so I can do the other one on the right side. And so put it on right here. Y minus y1 equals the gradient of ya equals the gradient of line 1 into x minus xa. This is xa and this is ya right here. So it becomes y minus ya is 3. Gradient of line 1 is a third. Bracket x minus xa is -1. So it's minus -1. So it's minus becomes a plus. And so multiply the 3 across here and recognize that this actually is a plus, right? This is actually a plus. All right, let's do the calculation. So it becomes 3y minus 9 equals x plus 1. I'm going to carry 3 across these two to get this. All right, and then all I have to do now is transpose this minus 9 over here and add it. And so I get 3y equals x plus 10. This is the equation of line 1. I'm on the line 2 on this side now. Right. That's the line 2 right beside it over here. Line 2. Line 2. Yes, the line 2 is perpendicular to AB. That's what they told us. That's how we're going to find the gradient. Now the point that we're going to use on line 2 is B. Line 2 passes through the point B. And that point is 3, 1. Remember, not to find the equation, I need the gradient and a point. So we're going to write down what we know. We know the point. All we don't know is the gradient. So see here, the gradient of line 2 is -1 over the gradient of AB because they're perpendicular. This is B. Where, let's work out the gradient of AB now. Because AB passes through those points. AB passes through the point A, which is -1, 3, and B, which is 3, 1, B, which is 3, 1. We can find the gradient of AB right here. The gradient of AB is a difference in y over difference in x. All right? And so it is, let's say we're doing this point minus this point. And look at AB. AB is supposed to have a negative gradient, right? You can see AB is sloping downwards. See there? All along AB you're going down. So AB has a negative gradient. And if you look at the line 2 is sloping upwards. So L2 will have a positive gradient when you flip it, flip and change the sign. All right, so come back over here now. We're doing this point minus this point. All right, so it becomes 1 minus 3. That's 1 minus 3. Difference in the y values divided by 3 minus a negative 1. Difference in the x values. 3 minus negative 1. That's what you get. So the gradient of AB becomes negative 2 over 4. And so the gradient of AB is negative half. Got 2 over 4 is half. Negative half. All we're doing so far now is trying to find the gradient of AB. Trying to get the equation, but we need the gradient. So based on that, now we can flip this and change the sign, and therefore write what the gradient of line 2 is. So that's the gradient of AB now. So based on this, it means that the gradient of line 2 can work it out. Flip and change the sign. Right? So we can say, therefore, blue, purple. Therefore, the gradient of line 2 is, you flip negative half and change the sign, it becomes 2. It's 2. So that's the gradient of line 2. So now for line 2, we have the gradient and we have the point. So we can now do the equation of line 2. All right, so see here, equation now of line 2. Line 2 passes through B, another gradient of 2. So the equation is going to be y minus yb equals the gradient of line 2 in the x minus xb. I put in the values now. Y minus yb is 1 right here. 1 equals the gradient of line 2 is 2. 2 into x minus xb is right here. 3. 3. And you solve this now. So y minus 1 equals 2x minus 6. Over this negative 1 and add it. And I get negative 6 plus 1 is negative 5. So y equals 2x minus 5. So this right here now is the equation of line 2. And by C, we're trying to find the numbers. So now that we have the 2 equations, look back at this. Now we have the 2 equations, right? We have the equation of this one now, and the equation of that one. C is just the point where those 2 lines meet. And so all we have to do is solve those 2 equations simultaneously. Right? All we have to do now, solve the 2 equations simultaneously. Right? That's all we have to do now. So now that we have the 2 equations, let's go and do it up here. So we can say now at C, at the point C, that's what I wanted to start with. At C, 2 equations are valid. Right? 2 equations that are valid now. 3y is equal to x plus 10. And at the same time, y is equal to 2x minus 5. The 2 equations are valid at the point C. Because the 2 equations pass through the point, the 2 lines pass through the point C. So C is the point that satisfies those 2 equations. So to solve them simultaneously, you can just use a substitution method. And this y, I'm going to bring that y value and put it here. Substitute it. So substitute them one to the next. Right? And when we do that, you can say, therefore, at C, 2 lines valid. Right? 3y is equal to x plus 10, and at the same time, y is equal to 2x minus 5. So therefore, we're going to get 3 times 2x minus 5. That's 3 times y equals x plus 10. I'm solving this now. This is 6x minus 15 equals x plus 10. Watch this now. Here over the x and subtract it, we get 5x. 6x minus x is 5x. Here over the 15 here and add it, we get 25. See, we get 25. And so x equals 5. And then now, if x equals 5, we can just put back the 5 in this equation to find the y value. So we can say, and y equals 2 times the 5 minus 5, which is 10 minus 5, which is also 5. What we did here, we substituted in the equation y equals 2x minus 5. That's what I did there. Substituting that equation. Right? And say x equals 5 and y equals 5, and therefore C is a point 5, 5. All right, so this was a question basically that encompassed almost everything that we did with parallel and perpendicular lines. And we applied the concept that at a point of intersection of 2 lines, if you want to find a point of intersection of 2 lines, you have to solve them simultaneously. All right, so that's a nice question. All right, if you can understand and do this question for yourself, then you're on your way to doing this topic. All right. So the concept with this question is that you want to find the point C. C is the point of intersection of line 1 and line 2. So you need the equation of line 1, and you also need the equation of line 2, so that you can solve them simultaneously. Talking about line 1 first, over here. Right? We know that line 1 passed through the point A. So put that down first. But then we need the gradient. Remember, to find the equation, we need gradient at that point. Question told us that line 1 is parallel to OB. But they didn't show OB on the graph, but we put it in. See there? We draw it in and show that them parallel. Cool? That's what we did. And because OB passed through the point O, which is 0, 0, and the point B, which is 3, 1, we are able to find the equation of OB. Not the equation, the gradient of OB, which is what we did here. And because them parallel, it means that the gradient of line 1 is also equal to the same 1 over 3, which is the gradient of OB. And then now that we have the gradient and the point, we put the gradient and the point in the BFF formula to get the equation of line 1. That's what we did. All right? And we worked on the equation, see here, and it carried on to the simplest form right here. I'll put that down one side. Then over here now, we went to try to find the equation of line 2. Remember, we need 2 equations in order to solve them simultaneously, find the point C, So for line 2 now, they gave us a point. So we have a point already. But to find the gradient, they told us that the line 2 is perpendicular to AB. So if we can find the gradient of AB, we can flip it and change the sign, and then that would be the gradient of line 2, which is what we want. Because in order to find the equation of line 2, we need the gradient of line 2 and the point, which you have the point already. So to find the gradient of line 2, we're going to use the fact that it is perpendicular to AB. And so the gradient of line 2 is equal to the negative reciprocal of the gradient of AB. So we had to calculate the gradient of AB, which is what we did here. Using the 2 points on AB, calculated difference in y by difference in x. And that led us that the gradient of AB is -1/2. And then to get the gradient of line 2 now, because it's perpendicular, we'll flip this -1/2 and change the sign. And so the gradient of line 2 is 2 right here.
Excuse me, sir. My Wi-Fi went away a while ago. What did
Yeah,
you
man,
do?
everything is recorded. Everything is recorded. So we can't start over. So if the Wi-Fi jump over, we can't start over. So you just have to catch it on the video. All right. So we have the gradient of line 2 now. So now that we have the gradient of line 2, and we also have the point B. We're going to use both of them again now and put both of them in the BFF formula right here to get the equation. That's what we're doing next, to get the equation down here. And then once this is the equation now, y minus yb equals m into x minus xb. That led us down to this equation. That's the equation of line 2. And now that we know the equation of line 1, and we also know the equation of line 2, we solve both of them simultaneously now down here. Why? Because C is a point of intersection of the two lines. You can see it here. See there? C is the intersection of this line and this line. So you solve them simultaneously. So that's why we have to get the two equations. Right? So now that we have the equation, we can say at the point C, first line is valid and the second line is valid at the point C. So at the point C, 3y equals x plus 2, and at the same time, y equals 2x minus 5. So we're solving them simultaneously. So we're going to substitute for the y value. I'll substitute that value into the y value on the other line there. And that led us to this equation right here. Right here is where the y was. I'll substitute for the y. And they will right down, it carried us down to x equals 5. When we get x equals 5, we take x equals 5 and substitute it in this equation right there. Right? That is what is happening right here. Right? This is where the x was. I put 5 there. Right? And that tells me that is 10 minus 5 is 5. So at the point C, x equals 5 and y equals 5. Right? And therefore, C has a x value of 5 and a y value of 5. And so C is this point right here. And that right there is your answer to this question, which is what you're required to do. You're required to find the coordinates of the point C. This is 5, 5. Or this is not, you won't see a question like this at your level, but if you can do a question like this, because the components of this question is what is on your syllabus, you're just putting it all together. So maybe at your exam level, might ask you to do one little thing or two little things, that stuff. But you putting all of this together in a question like this, right, is really, if you can understand and do that with this question, then it means that you're on your way to being able to solve any question on this topic. All right, which is the aim. All right. So as I said, what I wanted to do is actually now go and do the worksheet questions. Where is it? These questions. Try those questions of homework. If you don't have it, I can take a screenshot. Or let me know if you don't have it. But we have the handout supposed to have these questions. So these questions are the questions I want us to look at to start the next class. All right. I want you to look at these questions to start the next class. Cool. These questions. Those questions. All right. So that's it for today, guys. I'll post the video. I'll watch it over. We did a lot today. All right. Have to keep working. This is very easy. Just need practice. The exam questions won't be as nice as the one that I just did. Trust me. It's gonna be much easier. All right. But I wanted to be able to do even more structured questions, because if you can do the more structured questions, then you'll be able to do like a baby question that they'll set in the exam. All right, so I'll give you a question that are of a higher level than the exam, and then we come right down to the exam level. And those simpler questions, you can run through them a lot easier. All right, so watch over the video, try this question yourself. All right, try the ones that I did in the class, write them over back first by yourself. right? And then you try these homework questions on this page here. Try them, right? Try these questions over here. Right, try all these questions over here. Try them. Right, I want you to try those questions. Right, try them. Don't joke around. Try the questions. You can't do math without actually doing work. All right, so that's it for today, guys. That's it for today. We shall have. I can actually mark on it. No, I can't mark on it. Let's go back. Yeah. All right. We shall have some fun with these things on Wednesday. And you get a nice classwork. Cool? Okay, bye, guys.
Yes, sir.
Yes,
All right.
sir.
All right. Don't joke around.
Yes,
Go
sir.
and go and practice. Don't joke around with this thing, right? Go and practice. All right then. Cool. All right. Bye.
All right. Later, sir.
All right then. Bye.
Dad.
Bye, guy. Bye, guy. All right. Bye.
Bye, sir.
Bye-bye. Cool. All right. I'm ending the session now. All right. Bye. End it now.